Okay, it looks like we are live. Welcome everybody to Stacklock's second stream. So we're quite new to this, and we've got something pretty substantial to show to you all today. Something that I've personally been quite excited about. Something very novel, makes sense in retrospect, but we'd never really considered this an option. Okay, so you'll find out more what I'm talking about as we go into this. But let's start. I'd like to welcome my esteemed guest, Mr. Nigel Brown, somebody that I've known for quite a few years. But Nigel, I'll let you introduce yourself and tell the folks a little bit about Nigel Brown.
Okay, well, I'm Nigel Brown. I live in the southwest of the United Kingdom in Devon. I have been doing software since the early 90s, and actually really since before that, since I was about 10. And I've worked a lot in security, a lot in mobile devices, early Internet of Things, and latterly I've been working in data. All mostly with a security slant, and there's been some data science work. So I am very much a jack of all trades, and I was one of the early joiners at Stacklock, courtesy of Luke. Thank you very much, Luke. I'm having a great time. And yeah, I've been here pretty much from the start.
That's right. Interesting little snippet here. My very first job, I was a junior support engineer, and Nigel was one of the more senior engineers there. So I've always looked up to Nigel. So it's kind of quite interesting for us to be in the situation that we're in. And yeah. So anyhow, let's get on to the topic for today. So we're covering something called historical provenance. So Nigel, over to you. Tell us all about historical provenance.
Okay, right. So there's a whole host of slides coming up. Don't be scared. I intend to go through the first 10 very, very quickly and take a bit more time over the last 4. So what we're talking about, what is historical provenance and why do we do it? The general scope is the supply chain, right? As developers, we want to trust third-party code. We can't write it all ourselves, and just lately, because of some high-profile cases, we are being held responsible for what we actually download. And the point of this is, how can we trust it? You know, what can we do? There's actually quite a complicated web of trust we weave to do this, and I'm going to go through this now. So hold on to your hats. This is going to be quick. If you want to see this in a little detail, you can slow down the video later and play it back. The slides will explain themselves. And then a bit after the rest of the background, we'll do a demo, which is what we're all here to see.
Awesome. So you're setting some context for us here, Nigel.
Sorry?
You're setting a bit of context for us.
This is a bit of context for the background. Okay, so bear with me. Okay, so third-party code normally gets delivered as some sort of package, and we want to trust it. The package lives somewhere, and the source lives somewhere. So we have a source and a package repository. Each package has multiple versions, which complicates things a little. Normally delivered as a bag of files, and of course we can do things like scan this for known vulnerabilities, and we can also do generic code analysis for complexity and things. And we should probably do those things. We're not actually talking about doing that at the moment in this talk. This is about something else. Now, the code has an owner. You can't trust code, and what we really trust is the owner. That's one of the core principles here, the key point. We trust people, not code. And most open source code, and in fact, even closed source code has contributors. We have to trust them too. And we trust them by reputation normally. And the reputation comes from personal knowledge of them, from a community, from media. We normally do this without thinking. And it also comes from companies as well. People work for companies, companies sponsor software, and we give people more or less credence based on the company they work for sometimes. And to make matters more confusing, this whole thing is transitive. So that means that for each package, it's generally made up of a number of other packages, and they're made up of other packages. And an average is about 1,500 packages deep for a medium-sized project. And this is the web of trust I was talking about. It's quite a complex thing. It can be attacked at any point, and it can break at pretty much at any point. And this is not unique. There are thousands of ways we could draw this picture. This is just one of them. The point is that it's actually quite a complex thing. So we're going to break this problem down, and we're going to look at one tiny little bit, and that is the link between the source repository and the package. Package is claimed to come from a source repository. And the question is, do we trust that link? We can answer the important questions to some extent. Where did the code come from, and how do we know? And that's the aim of, that's called provenance, and that's what we're actually trying to do.
So Nigel, where you used the case of a SCA earlier, effectively, if you're going to perform SCA against a code base, you want to be sure of where it originates from, effectively. So to be able to perform credible actions, you have to make sure that it's an authentic set of origin that you have effectively. Know exactly what you're scanning.
Yeah, especially for binary-based formats. If you've got something download source like Python, you can actually do it on the thing you download. But otherwise, yeah, you do have to verify this link between the source code and the package. So for something compiled like Go, this link becomes important. You have to prove where it's from.
And as a quick follow-up question, I guess the metadata that's provided by the package managers can't be trusted, because quite often they'll tell you about the repository that the package came from.
Most of this information was self-reported in the past and wasn't verified. I think there is a little bit more verification now. There is some, but it's coming in slowly. Because you can't trust some of these links, because you can't trust some of the things that are claimed, it's best not to trust any of them unless you've got some form of evidence.
Makes sense. Yeah, I can see the case now for provenance. Yeah.
Okay. Yeah. So we're talking about historic provenance. So prehistoric, and that's just a joke because Sigstore is still pretty new. There is a way of ensuring that the package you download is where it comes from, where you think it's coming from. Its provenance is good, and this is a thing called Sigstore, and it's basically code signing that gets presented in a transparency log. Luke, you know way more about this than I do, and I'm sure you would talk about it all day if I gave you the chance, so I'll move on. This is the right way of doing things. This gives strong guarantees. Unfortunately, Sigstore signing is still quite rare in the wild, and historical provenance is a thing we can do until we get there. So Sigstore's the target. This is a fill-in. Right, so the new idea is quite simple, right? We get a list of the versions from the package repository. We get a list of the version-like tags from the source repository, and we see if they match. Right? And it's a very simple idea. And we look at it, and they do seem to. You've got versions on the red and tags on the blue, and the common ones are where they meet in the middle. So they seem to match, but the question is, how well is this going to work? So we took a sample. This is a sample of 60, random sample out of our database of 63 packages, I think, limited by the size of the screen because obviously the writing is quite small here. On the left, we have the packages that were downloaded, and on the bottom, we have the source repositories that they claim. Okay, and as far as we know, these are all reasonable packages, and there's no one doing any typo squatting or anything weird here. So the diagonal is where we expect them to match. And as we can see, there is a diagonal here, and it's very, very strong. Now, quite honestly, when I first saw this grid, I was shocked. Things that you try like this don't normally work this well. However, there are a few cases in which it doesn't work. So where does it go wrong? Well, obviously, if we're comparing tags to versions and there are no tags or no versions, then we can't say anything about it. So it is also true if we can't find the tags. They might be there, but we can't find them for whatever reason. May not have permissions. The package might not use tags. There could be unusual version patterns with odd characters in them. And there can be other bugs as well. We've got issues with lightweight tags.
But they're generally the outliers, you'd say.
The what, sorry?
They're the outliers. They're the fringe.
No, I wouldn't
suggest
say
that
outliers, but the bugs are outliers, yes.
Yeah, makes sense.
It's generally, on the whole, this does seem to be working. But there will be corner cases. Obviously, one of the jobs we've got over the next few weeks and months is to fix those. It's a brand new feature, so it's not going to be perfect right now. It is live though. Okay, so to compare this to historical provenance to Sigstore, because I don't want to frame this as a replacement, because it's not. It's an interim solution. So on the left, we've got a column that is not Sigstore, and on the right, we've got a column that is Sigstore. And the differences are basically that the links in Sigstore are to the actual binary you download, whereas the links in historical provenance are to the package repository. Historical provenance doesn't work all the time, as I just described. It depends on behavior, whereas Sigstore works all the time. Historical provenance is a fallback. Use Sigstore if you can. This is historical provenance is not a replacement. Historical provenance is available now, and Sigstore is rare but gaining momentum. And historical provenance is hard to spoof, and Sigstore is impossible to spoof. So there is a bit of a trade-off there. Okay, do you have any questions on what I've said so far before I go to the demo?
So there is a few questions. So Seth's on. Hi, Seth. And yeah, he rightly points out that there's some work happening with a trusted publisher receipts. And so I know those folks are doing some good work, as is NPM's another one that's adopted Sigstore. So there's some good in the background to this historical provenance is some
yeah, I think we're aware of those, aren't we, Luke? We're, generally speaking, we're trying to encourage those, and then I try to emphasize that this is not a replacement. It's a kind of a fill-in. So yeah, that's all good work going on, I think.
And another from Rohit here. What are some vivid antidotes to anchor risk discussions about untrusted metadata?
Oh, I didn't hear that. Sorry, Luke. Can you repeat that?
It should flash up on the screen. So what are some vivid antidotes to anchor risk discussions about untrusted metadata? Meta web of metadata, meta trust in metadata. So I guess this is effectively something that you're going to speak on later, which is the annotation system, which is where we have untrusted metadata. So we'll cover that a little bit later. Right here, that's a really good question. And let me just see, there's some more questions. I think that's it for now. I think we've got through the questions. Yep.
Okay, right. So moving on then, we'll demo some of these. Okay, so we've got a few demo cases here. So we'll start off with Next, which is an NPM package, and it has Sigstore provenance, and we'll see what that looks like on our UI. Okay, so if we look in here, this has got quite a good Trusty score. For those of you who haven't seen this UI before, there's some information, generic information about the package on the top left here. There is an overall score on the right with details. I'll go through there in a minute. We're talking about the proof of provenance is our proof of origin here, and we do some security checks. And down the bottom, we have a list of similar packages that might do a similar job if you're lucky. Okay, so it's some suggested alternative packages. So if we look at the details for the provenance on here, this was working pretty much before, but this gives you basically the Sigstore provenance from the transparency log, gives you the annotations there. Again, I expect Luke could talk for a long time about that. I want to show this for the sake of contrast, because that gives you an assurance that this package comes from this repo, which is claimed here. Okay, so you can be sure that comes from that place. And if we look at the
sorry, Nigel, didn't mean to interrupt, but it's quite an important point. really for Trusty to operate well, it needs to have good provenance guarantees as well, because it's calculating scores and so forth.
Yeah. So if we look at the detail here, we measure a few things. For instance, one of the things we have is, or two of the things we have, the activity in the repository and the activity of the authors or the contributors. Okay, now those are kind of irrelevant if the package is pointing to a source repo that it didn't come from. So that's an attack called starjacking. We'll come to that in a bit. So we need to we measure these things, the activity and on the author and the repo, but we modulate them with the provenance score. And given that you can't really spoof Sigstore provenance, we give that a score of 10. So that means that the maximum that the Trusty score can be is 10. And this one next actually has it scores 10 for the repo activity and 9 for the contributors activity, which is it's pretty much as high as you can get. So it's very good. So if we look down here, we look at some of the security checks. It's actually said that it's identified some potential supply chain attacks. It's an information. It's not a warning. Okay, so what it's found here is we're looking. There's two main boxes here. We are looking at repository affiliation, which is basically packages that share the same repository, and typo squatting. Now these are packages that also claim to have the same repository as Next. Now these have provenance. They have varying scores, but they look like they are legitimate packages that come from the same repository. If we scroll down the list, though, and these are sorted in, this is what it was saying was interesting, is that there are actually more than one package that share the same source repository. That's interesting, but it looks legitimate here. If we go down, there are some others here which also share the same source repository, but they have no provenance. So there's a chance that these are people either mucking around or they're actual starjacking attacks. Someone's trying to claim a repository that isn't theirs. They've got some project that they want to increase their reputation with. And that doesn't work in Trusty because we look at the provenance. So these are all these are to be, you wouldn't want to download and use one of these apps, I wouldn't think.
And so the first few, Nigel, I guess they're a common case of a mono repo.
Yeah. This is what I'm assuming. I haven't spent a lot of time looking in the Next repository, but I'm assuming these are different builds or they're different libraries from the same repository, and they look perfectly legitimate. So moving on to here, we have some similar names. Now, these similar names are interesting because you can, if you've got a project called Nuxt, for instance, you might be trying to pretend that you're Next. Now, it doesn't actually look like that's the case in this, because this is got reasonable provenance. So it's got a provenance, historical provenance, and it looks like it's probably just a coincidence, an NXE, an EXT. It's just a coincidence that they have similar names. So they're probably legitimate packages that just have a similar name. Nest, Nixt, Nexty, they could be typo squats, they could be accidents, but there's no provenance, and there's low scores. So that's probably not what you want to be using. So if you, for instance, try to download and use this net file, it would tell you that Next is probably a better choice up here. Okay, so that's the security checks there. So go back to, that's the demo of the Next package. If we go here, then we'll have one that actually has historical provenance. So this is Pandas, familiar package to some of you. The overall score looks, the overall display looks similar. So this time it said that we've got historical provenance. And we've also got a score of 8. So let's have a look at the score, the details of the score. Now this time, the provenance score is 8. Now that's because we consider historical provenance to be less strong than Sigstore provenance. Okay, so if you look at the activity in the repository, these are very active. This average should be, this score would be over 9 here as a score, but it's been modulated down to 8 because the maximum score you can get with historical provenance is an 8. Okay, so if we look at this now, if we look at the details, we'll see some more of what's going on here. So what this is saying, this panel is saying that we have found 186 tags in the software repo. We found 106 versions and 59 of them matched. And that, if they match, that means they've got a similar version pattern, like number, and they're on the same day. That's what we consider a match.
And so for somebody to try to spoof that, they'd effectively need to go back in time.
Yeah, depending on the type of tag, you would have to. So far, we found that any matches is a good sign. But yeah, these matches go back a number of years. We only show 1 year here at the moment, but they go back a number of years. So the more matches you've got, literally the better. And without access to the databases either in the package repository or the source repository, you would have to retrospectively do a release in August last year or February last year, and then with the same number, and this would be quite hard to do. So yeah, it would be quite hard to spoof. And that's what I said in the previous slide, actually. This is hard to spoof. It's not actually possible. As time goes on, it will become possible, but very difficult at the moment.
Makes sense, yeah. And I just wanted to mention, when we were speaking about it earlier, we spoke about Sigstore being a source of provenance, historical provenance being a source of provenance, but we're not expecting to sort of ring fence people just around those technologies. If a community came up with a robust approach using strong cryptography, then we would definitely pull that in and consider that a source of provenance as well. So we're just trying to make the best of what's out there.
Yeah, we would pull anything in. We want to show everything we possibly can. Basically, the philosophy behind Trusty is to look at everything we can and report it. It's really all the things you would do if you were doing this by hand, but we're just automating it for you. And the point about the transitive repository, the transitive dependencies, is probably important, because you could probably do most of this by hand for one package, but when you've got 1,500, it becomes a lot harder, and you want some help scoring this.
Sure.
Okay, so looking at these security checks, we've got no packages as claiming the same repository, which is good. Okay, that saves us worrying about that. But we have got some interesting typo squat type things going on here. So PSNDAS looks like a typo squat. We don't actually have any provenance information for that. So it's given a 5 for that, but Pandag as well, and that's got a lower score. So let's have a look at Psandus. I don't, you can't say it. Psandus. Okay, so if we look at the details of this score, actually that's only got 2 versions. It's got none tagged and none matched. So that's probably not something that you want to download and use. But if, on the other hand, if it is something you wrote yourself and you called it Psandus for a reason, it might be a perfectly decent piece of code. But it definitely warrants more investigation. So, yeah, no provenance say that repo is what it says it is. Let's have a look. What does it say it is? Oh, okay, here we go. So this is claiming the repo of Piper's sample project. Okay, which is a very it is a very active project. There's a lot of contributors to that, and a lot of activity there. However, we don't believe it is actually part of sample project. It's just someone that's put that information in there. So that's Starjack.
And I just add as well that we plan to do to release a system where the community can effectively flag around false positives that we have, or so there's a legitimate case which the system is seen as suspicious. They are able to annotate and express a view that something is legitimate, and we'll endeavor to be doing the same ourselves as well. So the system may come up with an opinion, but it is not static. Sometimes you need a human arbiter to settle a decision that a machine can't.
Racing well ahead of the slides here, but what you're saying is absolutely correct. Yeah, we'll get back to that probably in a minute, not in any detail because we've only got half an hour here. Right, so that was that example of pandas. Something was typo squatting it. We've got no provenance, an example with no provenance. Redux counter, and I don't know what these. I don't know what these packages actually are. I haven't spent any time looking at them, but this has a very low score. So if we look at the details, the provenance is 1 because it doesn't have any. So the score is 1 because it doesn't have any provenance. So although it's got a very active sort of set of packages, the overall score is low because we don't believe that. All right. So there is okay. So this is the details. So we've got 3 versions and 80 tags, and none of them match. This is where we're sort of saying, okay, we've got no evidence. I mean, it might be that it comes from the right place, but let's have a look at the security checks. Okay, we've got a little warning now. So it's identified a potential supply chain attack. Review is recommended. Please view the details for further information. I think that's a good idea. So although we're looking at a package called Redux counter example, and it's claiming this repository Redux.js is actually a package that shares this repository that has got provenance. So if we look at Redux here, we'll see that actually that as part of all the security checks, we look at the detail. Oh, that's got Sigstore provenance. Okay, so we know that this package comes from this repo. So this is looking like a fake, this one. So let's not download a Redux counter example. Although there are no typo squattings because it's a long word. Okay, but yeah. So we found another starjacking example there. And although it's not typo squatting, it does have a similar name, Redux counter example. Okay, right. So we'll go on to the next example. No tags. Here we go. This is one of the ways in which we look at the details of proc macro 3, and it's coming from this database proc macro 3. Here we view the details. There are just no tags there. There's 2 versions, nothing matched. This is kind of unless you own this package, there's very little to recommend it to you. There's no activity in the repository of the author. The provenance is a 5 here because we can't say anything about it without tags. This is one of the corner cases where this doesn't work. Proc macro 3, and it says actually nothing is trying to typo squat it, nothing's trying to starjack it, because basically it is the lowest common denominator. So that is much of what we can say about proc macro 3. But if we go now to a starjacking repo, this is an example of starjacking repo, proc macro 2. This is a crate. Let's have a look at what this one says. Okay, proc macro 2. This is saying that it comes from GitHub DTOL NAI proc macro 2. Saying we can't actually match. There are 95 tags and we can't match any of them. Okay, doesn't sound great. We'll look at the score for completeness. So we've given this a very low provenance score. It's actually quite an active repo and author contributors, but the score is low because we've got no provenance. So we look at this, the security checks. We've identified potential supply chain attacks. A review is recommended. Let's look at this. Okay, so Repository affiliation attacks checks. We've got something else that claimed it's in the same repo as proc macro 2, and it is in fact called proc macro 2, and it has provenance. So it looks like if we are using this package, what we probably wanted was to use this package. And if we go and check on there, we find that actually this has got quite a good score. We've got reasonable repo activity, good author activity. We've got one repository in the same repo, but it's got a very low score. No, this is the one we were looking at before. No provenance, so we're probably using the right one. And if we look at the details, we find there are 132 versions, 95 tags, 64 matched. The reason they don't all match is probably because there's either more than there are tags used for different things, so they're not all tags are used for releases. But getting some matches is where we want to be. Okay, right, we're running out of time now, so that's the end of the demo.
So just an interesting point on that last one. I actually typo squadded that proc macro 2 myself as a preventative method to stop people from putting something bad there. So it's interesting that it found that. So if you go on to, if somebody was to go onto Crates.io and search for proc macro 2, you see it's me effectively starjacking that package. But I've yanked it now, so it's not evil. So it's really interesting that you actually found that, because that's something that that I used as a kind of a staging mechanism to protect people. So
I didn't know that.
Yeah, so that was brilliant. Thank you so much. It's of course I'm going to be a bit biased, but I think this is an awesome system. It really has value out of the box. You know, being able to see suspicious packages, get a read on them before even finding out if they're malicious, effectively. You know, so it's an incredible, useful system. And I'd like to thank our audience, everybody that's come along today. Hope you enjoyed it. Lots more is coming. We have a lot more interesting features that are going to be coming online, so we'll be sharing about those regular. And once again, thanks, Nigel. All the best.
Well, we didn't get on to the annotation, but we mentioned that earlier, and questions can go in the channel on Discord. Okay, thank you very much.
Thank you.